Okay, to start the year off, we are going to review why the scientific method is important to use in science. Okay, so that's going to have 3 learning targets. You should be able to explain, identify, and apply all parts of the scientific method. You should be able to write a hypothesis, identify variables, create a graph off data, and be able to write a conclusion. You should also be able to explain whether an experiment is valid using the scientific method. Okay, so science, remember, is an investigation to gain knowledge about the universe. A method is a step-by-step procedure or style of research. Put the 2 definitions together, and the scientific method is a procedure scientists use to gain knowledge about the universe. So let's identify the steps. The first step is your purpose. Then you will form a hypothesis based on your observations. You will conduct an experiment to test your hypothesis. You will analyze the data from your experiment, form a conclusion. In that conclusion, you're going to decide whether your data supports or does not support your hypothesis. If it does not support your hypothesis, you will create a new hypothesis. So let's look at the individual steps. So step 1, form a question. Your purpose is always in the form of a question. And that purpose is based on observations. Remember, an observation is a form of investigation that causes the curious human brain to form questions. Observations can come from reading online, in books, or from examining the natural world around us. So once you make some observations, then you probably have questions. That question turns into your purpose for the experiment, for the scientific method. The next step is a hypothesis. So once you've got your question, you're going to make a prediction that can be tested. It's an educated guess based on old and new knowledge. So you're going to start and write a hypothesis. Remember, we always start off saying, I think such and such, because you have to explain and why you think the way you think. Then you're going to design an experiment. So remember, designing an experiment, you're going to provide step-by-step procedures that allow us to accept or reject a hypothesis. In your experiment, you have to identify your variables. Remember, the control is a standard for comparison. The independent variable is the factor that is changed by the experimenter. Remember, you only change one factor in an experiment. If you change more than one, we have no idea which factor had the effect. So we can't answer our question. So you can only change one independent variable. And that's usually what determines whether an experiment is valid or not. The dependent variable is what we measure. It's based on the independent variable. And then constants are factors that stay the same, so only one variable changes. And remember, your control is usually one of your independent variables. That's the standard. Okay, step 4, analysis and collecting data. So when we're testing the hypothesis, okay, we collect data in the form of graphs and data tables. Okay, data could be in numbers, which is quantitative data, or it could be written out like in the form of surveys, which is qualitative data. We usually take our data and we put it in graphs. Now, remember, data table, I'm going to draw a data table and show you how to remember how to label a data table. Okay, so if you look down here, when we create a data table for our data, we always put the independent variable in the first column, the variable we're changing. Then our dependent variable goes here. And notice, whenever we measure an experiment, we always want to do more than one trial. So we usually have a minimum of 3 trials. That reduces errors. And so that helps create a valid experiment. So remember, if you only have 1 trial, that's not a valid experiment. And then we always have to take an average of those trials. Then when we take that data, we're going to put it in a graph. So remember, on the x-axis right here, we always have our independent variable, whatever changing. So all you got to do is look at your data table, whatever the independent variable is, put it down on the x-axis. Then on the y-axis, we need to put our dependent variable. And that's because that's what we measure, so we have to come up with our scale for what we're measuring. Remember, we always graph averages. Okay, do not graph each individual trial. Please make sure that you're graphing only the averages on the graph. Then you have to determine what type of graph to use. So when we use a bar graph, that's when we are going to be comparing data. we will use a line graph when the independent variable is some change over time. So if time is our independent variable, or a change over time, change over weeks, seconds, years, we're always going to use a line graph. And then the last step of the scientific method is our conclusion. So when we write our conclusion, we always restate our hypothesis, and then we look and see if our data supports or does not support our hypothesis. Remember, you always write it as data supports or does not support the hypothesis. Don't write hypothesis supports data, because that doesn't make sense. Okay, so your data either supports or does not support your hypothesis. Okay, remember that the scientific method does not prove a hypothesis to be correct. It only gathers evidence to support or reject a hypothesis. Okay, so you can't say that I was right or that my hypothesis is correct. It's either your data supports your hypothesis or does not support your hypothesis. Okay, so let's kind of fill in this chart to make sure we understand the steps of the scientific method. So this guy, he has a question. So remember, that's called our purpose. He's made some observations and he has a question about the universe, about something in the natural world. And he wants to do an experiment to figure it out, to answer the question. So based on his observations, he is going to form a hypothesis, what he thinks is going to happen and why. Then he's going to design an experiment. He's going to design an experiment to test his hypothesis. And once he's got his experiment, he needs to collect and analyze results. So he's going to analyze his data. Then our crazy scientist guy is going to answer this question. Does his experiments and observations, so does his data, support his hypothesis? If it's yes, then he can form a conclusion. He can write up a conclusion and then share results. If his data does not support his hypothesis, he's all upset, he's like, no, then he's scratching his head going, well, I wonder what went wrong, I got to think about this, or maybe I made an error, or maybe I need a new hypothesis. So he'll come up with a new hypothesis, create a new experiment, and then go back through, analyze data, and answer this question. So that's how the scientific method works. So hopefully after the notes, you should be able to identify all the parts of the scientific method and apply them, be able to write a hypothesis, identify variables, graph data, form a conclusion, and be able to tell whether an experiment is valid or not. Remember, it is only valid if only one independent variable is changed and there are more than one trials tested. Okay, and make sure we do have another video on Learning Targets 1, 2, and 3 about using the metric system, so make sure you watch that video as well.